Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. So yesterday we were talking about the construction of the transistor circuit, that when we are having this type of the circuit, so NPN type of the transistor is connected with this circuit. So how would we know that is it NPN or PNP transistor? So I told you the basic definition that should be keep in mind, that all the times remember the direction of the arrow must be from positive to negative. So we are having the input part, this is an input part, and this is an output part. So talking about the input part, so to distinguish between the emitter and collector, we must have to put an arrow. Now the question arises, what should be the direction of the arrow, whether towards the emitter or towards the base? So I told you that all the times the direction of arrow must be from positive to negative. So here in this case, positive, if we are having NPN, if the direction is in this way, so it means it is an NPN transistor, because the direction indicates from positive to negative, means from P to N type of semiconductor. If for example its direction is given in this way, means towards the base, so it means it is PNP transistor, from positive to negative and positive, right? So we don't need to put any arrow at the collector side. So now it should be, I hope so that it is clear now, all the basics of this basic circuit. Moreover, the power is supplied from the input to the input, and that power supply is denoted by VBB, V and in subscript B and B, double B, right? So in this way, so the voltage source is applied to the base or the input, so that is denoted by VBB. Again, for the output we have to supply another power, we have to place another battery at the output side. This is an input side and this is an output side, right? So this also needs a power supply that is denoted by VCC, right? VBB and VCC. Looking at this figure, many things must be clear, that we are having a particular type of the configuration here. We are having 3 terminals of the transistor. So in this case, the emitter is put into the ground, means it is a terminal, it is the point in that is included in the input side as well as at the output side, right? So this is known as common emitter mode, right? It is a common emitter configuration, or somewhere in literature you will find as the mode. So emitter terminal is a common in this circuit, therefore it is known as the common emitter configuration mode. Yes, of course, the other two configurations are also possible and very common to in use depending upon the applications. So if the base is common, then common base configuration. If the collector is common in the circuit, so it is known as common collector configuration. So the difference is that so this will be, in fact it will be moved in this way. This is just to show that how it can be the common. So if we are rotating it, so the base is common, right? And similarly, if we are if the collector is on the ground and it is included as the input as well as at the output side, so that mode is known as common collector configuration. One more thing is that should be noted, that there is a difference of the power supply. Here the simple power supply is connected, here some more powerful battery is supplied. If it is single cell battery, so it should be the higher than one cell battery, 2 or 3 cell battery. Why? Because I told you that this input part must be connected in forward bias and this should be connected in the reverse bias. And ultimately the output will be taken from this collector side, therefore the higher power supply is needed in this regard. So the dear students, looking at the figure given in the book of Floyd, this is the same thing that has been described in the previous figure. So just try to understand the behavior of a transistor while we are connecting it in the common emitter configuration. So what happens, for example, this transistor is the NPN type. So base is connected with the power supply and collector is also connected with the power supply. So what happens if we are looking at this loop it works in the forward biasing. Why? Because this terminal is connected with the positive lead of the power supply, positive to positive. So it means it works, or it functions in the forward biasing, because it is here the holes or the positive charges are majority carriers in the P material, but this is thin material, remember, and then this is the direction of the flow of current or flow of charges. On contrary, we are having the output part, and this is the output part. So what happens, although it is connected with in the reverse biased, how can we justify it? Because N type material is connected with the positive type, positive lead of the battery. So here electrons are the majority carriers in this N type material, and it is connected with the opposite polarity. So this works in the reverse bias, as we have discussed thoroughly in the diodes. If we would like to make the forward biasing, so what will happen? We will connect the same polarities of the semiconductor and the battery. If we would like to make it in the reverse biasing, then what happens? We are connecting the opposite polarities of the battery and the semiconductor. So I hope so that you can recall your memory. So this is all given in this circuit. More precisely, this figure is given in which this is what the emitter, base and collector. Some shaded areas here, the black shaded areas are showing that obviously when the electrons are moving around, then the path is given, so little flow of the electrons take place from the base terminal, because the path is given. Wherever the path is given, the electrons may flow, but this flow is very minute. Obviously it will be considered in any equations we are drawing, but despite of that it is minute. So we can say that this is the IB. IB indicates to the current in the base. Again, what happens? The current flows into the collector side, can be denoted by IC. C is the subscript, here the B is subscript. IB, small subscript, means base current, collector current and emitter current. So what happens, students, coming to the figure this, here the electrons are the majority carriers. When it works in the forward biasing, the flow of the current moves in this direction. Here what happens, this flow of the direction means electrons makes this p-type semiconductor material as the majority carriers, although here the majority carriers are the positive holes, but we are having the flow of electrons and this is a thin layer, so this causes the diffusion of the electrons to the base region. This causes the diffusion of electrons to the base region because of this flow of the electrons. When now assume that this base and this emitter is populated with the electrons, so what will happen? These electrons will be attracted by this polarity. The majority carriers become the electrons, although the electrons are already majority carriers in the n-type. On the other hand, plus more electrons are passed through this n to base, n to p and p to n, and they are attracted with the positive battery, and this flow is in this way, clockwise. Although somewhere you will find in the literature the opposite direction, and that indicates the conventional current, as we have discussed in the classes. So what happens? In this way we are having the flow of electrons, and that is the reason by where we are obtaining the high current from the collector side. Therefore it is the output. Anywhere we are putting any load, then what will happen? This is the caused, or it obtains the output at the collector side. So recalling that it works in the forward biasing, the electrons are the majority carriers. They try to diffuse these electrons into the p-type material. Although the p-type material is thin material, so it causes the majority of the electrons over here also, and when the majority carriers are the electrons and n-type is already having the majority carriers electrons, these are attracted through the positive polarity of the battery, and this is the flow of electrons. So in this way, by using in this configuration, one part at the reverse bias, forward bias input part is connected with the forward bias, and the second part is used as the output part, where the emitter is common in this particular configuration, remember, and it is quite possible another two topologies or configurations are also available, which are known as common base and common collector configurations. Depending upon the applications, obviously these circuits behave in different modes. For example, in UHF you have gone through the televisions when you are setting or tuning the signals, and you will find that UHF and VHF signals are there. So this type of the circuit is best for these UHF and VHF signals. Moreover, we can consider these figures which elaborates this concept in more detail. Dear students, look at these figures. This is an NPN transistor, and the direction of the current, I told you that IB subscript B indicates the base current, and C indicates to the collector current, and E indicates to the emitter current. This is the direction of the current means base, from base it is input direction, and IC, from IC it is having the invert direction or towards the emitter direction. Why? Because it is ground. It is ground. Therefore, both the currents are recombining with the emitter point or the terminal. So schematic is given symbolically. This is the direction, the same directions are there. Similarly, if we are having the PNP direction, then what happens? The main current or the input current is from here, and these are the output currents, right? So in this way we can draw an equation that is very fundamental equation of the transistors, that the emitter current is equal to IC current plus base current. I told you that there are the paths given. So coming back to this figure, so some current flows from here and majority electron charges or flow of electrons are in this direction. So what happens? According to Kirchhoff's law, recall your memory, according to Kirchhoff's law, so what happens? The input current is equal to the all output current. The input current is equal to the all outputs of the current. So here what is the case? IB is, in this case we can say that it is the current is due to the emitter. Emitter is the major supplier because it is a grounded. So what happens? IC plus IB is equal to the IE. So this is a fundamental equation that is drawn from this scenario. Students, now we will analyze the DC load line analysis, that is an important topic of your syllabus. So what happens? This figure is obtained from the Floyd book. So same things are written over here. Just to recap them, so this is a transistor, and this arrow direction shows that it is an NPN transistor because it is the positive terminal and it is an N terminal. Obviously it must be the N terminal. So it is an NPN transistor, and the configuration or the mode or the topology is the common emitter configuration. So this current is known as IE, IC, IB. This is the voltage from base to emitter. It shows the voltage from base to emitter, the voltage from collector to base, and voltage from collector to emitter. These are different parameters which are brought into the consideration, into the analysis, and it shows the different operating points, in fact, that how the circuit behaves. And remember, this is the DC load line analysis. Why do we need to write the DC direct current, although we are using the electronic circuitries? So obviously by default it is direct current, it is not an AC, but I will show you here in a few moments that this analysis can be taken place for the AC load line also. and we will understand that what is in fact the basic need of this circuit. So these are some parameters written over here. Again, considering the analysis, remember, again we are having some input part and we are having some output part. So here in this, looking at this figure, we can draw different equations. For example, so we can draw a graph which is having the y-axis and the x-axis, and we would like to find the relationship between base current and base to ammeter voltage. Normally this current is found in the microamperes and this is in volts. So here we can see that this IB current is the point of interesting. In fact, we intend to find the values of the IB and the associated voltage, that is from base to ammeter voltage, VBE. So we can draw the equations. The first basic equation can be drawn in this way, that we are having the main power supply, that is the VBB, that is positive, minus IBRB, this is not in subscript, and in this way this is in the subscript. So IBRB, so this is what? Positive VBB, base voltage, right, minus IB into RB, minus VBE, that is equal to 0. This equation can be drawn, right? Similarly, now we would like, this is, remember, this is all is discussed for the input operating points. Again, we can say that we are having two different parameters, P1 and P2. Obviously, in this graph, we need some x points and y points. So in first case, the x is 0 and we have to find the y coordinate. In second case, we are given the y coordinate and x coordinate is to be found. To find the y coordinate, that is in fact the IB, to find the IB, we are assuming that this VBE is 0. This VBE is 0. Put VBE as 0. This BE is in subscript form. So put the 0 at the place of VBE. So what will be the value of IB here? Obviously it is 0. So IB should be VBB divided by so this IB is equal to the VBB and divided by RB. You can do it yourself. This is not I, this should be the R. So if we are considering the VB as 0, we find the value of IB. So first parameter is in this way. We can place 0 and then VBB upon RB. In second case, to find the x coordinate, we can put the IP value, this IB value as the 0, and then what happens, VBE is equal to VBB. This VBE moves into the right direction because of negative sign, and this becomes 0. So VBE is equal to VBB. So the second P2, here in the P2, VBB comma 0. These are some important calculations which must be kept in mind. Again, what happens? Obviously, this is the behavior of the transistor and the diodes, that if it depends upon the semiconductor material that we are using, what is the barrier potential of that material. Normally we have seen, for example, silicon is there, 0.7 barrier voltage is there. So till the 0.7, the line lies on the horizontal line, and then it abruptly moves into the flow of the electrons or the current, and current suddenly rises. So this is what we will discuss in next class, that how the Q points or the operating points can be obtained through this graph. At the end, I would like to make it clear. For example, this is the same circuit is given here, so I have made some changes in this circuit, that I have placed the capacitor over here and this way at the input side and the output side. So what happens, the current flows over here and current flows over here. What we need, in fact, at the input side, we are providing some sinusoidal signal from the input side, and this is a property of a capacitor. I hope so that you are well familiar with the basics of the capacitor, that it allows the AC signal and it prevents the DC signal. फॉर एग्जाम्पल, आपके लैपटॉप में कोई ऐसी सर्किट है जिसको AC पावर सप्लाई चाहिए, तो उस जगह पर, हालांकि हमारे पास लैपटॉप में DC करंट चल रहा है, लेकिन जहाँ पे आपने DC करंट को प्रोवाइड नहीं करना, आगे नहीं भेजना, वहाँ पर हम कैपेसिटर लगा देते हैं. For example, fan is connected with your laptop, so what happens, it needs the AC signal, so we are placing the capacitor according to the specifications or the values selected in the calculations, और वो कैपेसिटर आप लगा देंगे तो वो AC सिग्नल को अलाउ करेगा, DC सिग्नल को नहीं. So what happens here, we are providing the AC signal, and we will find and we will obtain an amplified signal, faithful signal. What does it mean? Faithful signal means as it is when you are providing a signal, the small signal, and this circuit is in fact is used. This is a basic purpose of this circuit that I am telling you now, that it is used for the amplification purpose. एम्पलीफाई का मकसद ये है कि अगर स्मॉलर सिग्नल आप इसे प्रोवाइड करेंगे, एसी सिग्नल, तो वो आउटपुट पे एक हायर सिग्नल के तौर पर आएगा और फेथफुल सिग्नल के तौर पे। फेथफुल सिग्नल का मकसद ये है कि ये कहीं से भी डिस्टॉर्ट नहीं होगा, डिस्टॉर्ट नहीं होगा कि इसका शेप कुछ इस तरह से बन जाए, इस तरह से यहाँ से ये डिस्टॉर्ट हो जाए, क्लिप हो जाए, इस तरह से नहीं होगा। सो एज इट इज़, फॉर एग्जाम्पल, वी आर प्रोवाइडिंग अ सिग्नल ऑफ 1 milliampere, so it may go to the 90 milliampere of the signal. So it is used for the power amplification purpose. It is used for the amplification purpose. This is the basic circuit, जिसमें जिस तरह से आपके पास माइक होता है, माइक में आप अपने वॉइस का एक सिग्नल हम देते हैं एसी, और उसको एम्पलीफाई करके आपके लाउड स्पीकर्स पे उस सिग्नल को दिया जाता है. So this is known as the amplification, to boost your input signal and provides the output signal. So thank you very much.